Hi guys, today we're going to be talking about chapter 4, and the section is not V, not 5, but U substitution, and let's get started. So essentially, all U substitution is whenever you want to take the definite or indefinite integral of a composite function, which looks like this. So let's just make this definite. So it's the integral from a to b of f of g of x dx. So what you do is you have to first so first you're going to want to choose a substitution for the inside function, or sorry, choose whatever you want to substitute, which would be by setting u equal to the inner function, so u equals g of x. And so next you want to take the derivative of this function, so you can compute du. So du equals g prime of x times dx. So by doing so, you can find what dx is and take that out of the equation as well. So dx equals du over g prime of x. And so you also want to change the limits of the function, which are a and b, by evaluating them at the u function. So the u at b is g of b, and u at a is g of a. So now we're going to rewrite the integral in terms of u. So g of b, g of a, sorry, g of b, g of a, of f of u over g prime x f of u over g prime x du. But this looks and you wanted to replace u and not an indefinite integral. In a definite integral, you're going to solve and never go back to x, but an indefinite integral, you're going to want to compute it back into terms of x, because that's what you were solving for in the first place, instead of an actual number, like what a definite integral will give you. So an indefinite integral, when using u sub, looks like this. And that would in turn give you this f of u du equals f of u plus c. So now that we've worked all of that out, we're going to find both an example of an indefinite integral and a definite integral using u sub. So let's start with the definite integral. So we have the integral from 0 to pi over 2 of 2 sine 3x, so 2 sine of 3x plus 5 cosine of 3x dx. And it's asking you to evaluate the integral, of course. So what we see here is that we have trig functions on the outside and trig functions of an inner function on the argument of the trig function is a function itself. So we're going to make, in this case, 3x equal to u. And then we can find du. So du equals 3 dx. And in turn, dx equals du over 3. So now and we also have to do the limits of the function. We have to rewrite those limits. So u of 0 is just 3 times 0, so that's still 0. And then u of pi over 2 is 3 times pi over 2, which is just 3 pi over 2. So now we have to rewrite the whole definite integral in terms of u. So we have the definite integral from u to 3 pi over 2 of 2 sine u plus 5 cosine u du over 3. And since du is being multiplied times a constant, we can move that constant 1/3 outside of the whole integral itself. So we'll just do that on the previously shown thing. So we're moving that 1/3 outside of the constant. So now we can integrate this, and we will get, so the integral of sine is negative cosine. One second here. Yes, sorry. One second. Yes. Okay, so the integral of a sine, is a negative cosine. So we have negative 2 cosine u negative 2 cosine u plus 5 sine u. Yes. At 0 and 3 pi over 2. And that's definite integral notation after you've integrated. So we're going to have negative, it's going to get tight here. We're going to have negative 2 cosine evaluated at 0, or sorry, evaluated at 0 minus, so it'll be minus another negative 2 cosine, so that'll end up being plus, so plus 2 cosine of 3 pi over 2 minus, we're just going to move the 5 outside, minus 5 sine of 0 minus sine of 3 pi over 2. And so cosine of 0 is 1. So we have negative 2 plus cosine of 3 pi over 2 is 0 minus sine of 0 is 0, and so minus 0. And then sine of 3 pi over 2 is negative 1. So it's negative 2. Oops, my bad. Yeah. It's negative 2. One second here. We're going to rewrite this. So we're going to rewrite this as 1/3 times negative 2 cosine 0 minus cosine 3 pi over 2 minus 5 of sine 0 minus sine 3 pi over 2. And so cosine of 0 is 1. Cosine of 3 pi over 2 is 0. Sine of 0 is 0. Sine of 3 pi over 2 is negative 1. So that negative cancels out, so it's minus 5. And oops, there's another negative out here. So that negative cancels out as well, and so you're left with 2 minus 5, 1/3. So that equals negative 3 over 3, which is negative 1. And they're not always that complicated. But now let's go for indefinite integral. And so we have the indefinite integrals are usually much more simple in some cases. So we have the indefinite integral of 9 times x squared plus 3x plus 5 to the 8 times 2x plus 3 dx. So we're going to make u x squared plus 3x plus 5. And so that would make du 2x plus 3 times dx, which is not a very usual case at all, but that actually helps cancel out this whole part of the equation. So this is just du now. When we're rewriting the integral itself because we've already found u and du. So now we can rewrite this as oh yeah, we also need to take 9 as a constant outside of the integral. So 9 times the integral of, this is u, so u to the 8th. We'll write this du closer. So that was a pretty quick substitution. And so we have when we integrate this, we'll have 9 times the integral of u to the 8th is u to the 9th over 9. So the 9 cancels out. And in the terms of indefinite integrals, as we said earlier, we've almost forgot the plus c. The constant isn't always necessary. As what we said earlier, we always need to, for indefinite only, we need to plug in the original equation back into u. So it's x squared plus 3x plus 5 to the 9th plus c. And that's it. In the words of Renu Descartes, cogito ergo sum. That's it, guys. See you next time.